All right, sample number 3. Back to Matthew's climbing robot, 15-watt motors, generate maximum torque with a 250. So it looks like that's the motors have a 0.05 Newton meter torque at stall and 250 to 1 gear reduction. He has a 1 centimeter diameter shaft. Will it transmit that torque without failing? Okay, so step 1, let's create a little schematic. So it looks like he's got his motor here, he's got some gear head, and now this is a shaft. The shaft has a sprocket. A little drawing for a sprocket here. And it looks like that guy is transmitting. Okay, well, that's putting some load, but this time we're going to look at it from the motor. So 2, now let's look at the free body diagram of the shaft. You know, so now we're just looking at the shaft. So like that. And at one end, we've got the torque going in. The other end, we got the torque going out. And our torque is given as the torque at the shaft is going to be torque at the motor times my gear reduction, okay? So, okay, so let's see how this is going to work. So my motor torque is 250. I got a 250 to 1 gear reduction. So I'm jumping once again to this little sheet that I gave you. And we said here that the torque out, which is our shaft, equals the torque in times a mega in over a mega out. Okay. So now we can start putting in numbers. So that torque motor was 0.05 Newton meters. And the mega in to mega out, we got a 250 to 1 gear reduction. That generally means that I get 250 rotations the input for 1 rotation at the output. Okay, so I'm going to read that because it's a torque increasing speed reducing gear train. So I can just calculate that directly. I'll jump over to MATLAB and do that. So get 0.05 times 250, 12.5 Newton meters. Step 3, that's now the torque. Now I'm ready to calculate my torsional shear. So that's torque times my radius divided by J. So it's going to be 12.5. My radius is 0.0. Let's work in, so now this time work in meters. So it's going to be 0.005 radius divided by pi halves times 0.005 to the 4th. And I got to check to see if that's less than or equal to my yield strength divided by 2 times 2. That 2 comes from the max shear stress theory, and that 2 comes from 3D printing. Because remember, I have this reduction of strength by 50%. So I now need to check and see if that's the case. This guy was 40 megapa. So, well, I guess we can do that one by hand. So is that less than 40 over 4, or is it less than 10 megapa? That's what we're asking. So I get 12.5 times 0.005 divided by the quantity, pi halves, times 0.005 raised to the 4th. 63.6 megapa. It is not, no, not less. No, not less. So this means this shaft fails, clearly fails. Fails by a whole bunch. Okay, that was easy.